Alright, in this video we're going to cover number 3 of 2017. This is a graph type problem. So let's go ahead and get started. Before we do though, you should have already done this on your own, so please do so if you haven't before you watch this video. Alright, it gives us, 2017, number 3, gives us the graph of f prime. Okay, we always want to make sure we understand what's given. It says the function f is differentiable in the closed interval -6 to 5 and satisfies f of -2 equals 7. So here you can see that we have an initial condition. The graph of f prime, the derivative of f, consists of a semicircle and 3 line segments as shown in the figure below. Find the values of f of -6 and f of 5. Well, because we're looking at the graph of f prime and we're trying to get to the values of f, we have to write an equation that represents f. And remember, this equation, the function for f is f of x equals the initial condition plus the integral of the derivative. If you're talking about particle motion, the application of particle motion, the position of a particle is equal to its initial position plus displacement. This is the same thing, it's just without the application. So we could say that f of -6 is equal to the initial condition, and so here we have an initial condition of 7. So 7 plus the integral from the x value of our initial condition, so the integral from -2 to the value that we want, -6 of f prime of x dx. And so from here we just need to simplify this, solve it. We are looking for the integral from -2 to -6. Now notice we're going backwards here. We're going from -2 to -6. So what I'm going to do is I'm going to flip that integral, so it'll say 7 minus the integral from -6 to -2. You don't have to do that, but I think it makes it a little bit more clear on what you're doing. So we end up with 7 minus the integral from -6 to -2. And so the integral from -6 to -2 is the area of that triangle. Now notice we're going from -6 to -2, so that means our base is a positive, in the positive direction, it's a positive length if you would, and then the height is a positive value. So we can say that the area of that triangle is 1/2 4 times 2, and then that simplifies to 3. So f of -6 is 3. For f of 5, we're going to do the same thing. F of 5 equals 7 plus the integral from -2 to 5 of f prime of x dx. Again, initial condition plus the integral of f prime, making sure that the x value of the initial condition is on the lower bound while using the y value of the initial condition. So here we don't have to flip this one because we're going from -2 to 5. So we would say 7 plus, well, from -2 to 5, we're looking for the integral from here all the way over to here. So I'm going to split that into 2 different pieces. The first piece is a semicircle. And because we are moving from -2 to 2, we are going to make that area a negative net area. So we end up with -1/2 pi r squared because the radius is 2. And this is a half of a circle, so we have the 1/2 there. And then for the triangle, the base of the triangle is 3, and we're moving in the positive direction, so +3, and the height is above the x-axis, so it's a positive height. So we can say that the area of that triangle is going to be 1/2 of 3 times 2. And then when we go to simplify all of that, it actually works out to be 10 minus 2 pi. So that is our value for f of 5. In terms of grading, you're going to get 1 point for using your initial condition. So basically, if you had your equation where you had 7 plus the integral from -2 to whatever, then you get that 1 point. You're going to get 1 point for f of -6, so this answer, and then 1 point for f of 5, so this answer. So you're going to be in trouble in terms of points here if you did not use the initial condition. If you didn't use it, you didn't get any points on part A. So you have to make sure that you understand that a function's value is equal to its initial condition plus the integral of the derivative. Alright, for part B it says, on what interval is f increasing? Well, because we're given the graph of f prime, we have to translate what we want into the thing that we have. So when is f increasing? F is increasing when f prime is positive. Or we could say when f prime is greater than or equal to 0. So f is increasing when f prime is positive, which means we are looking on this graph when it is above the x-axis. This is f prime. It is positive when it's above the x-axis. So we'd say from -6 to -2 and from 2 to 5 as our final answer there. As far as points go, we're going to say you get 2 points for your answer with your justification. So basically, if your justification is wrong, even if your answer is correct, you're not going to get any points. So be careful with your justification. As far as whether you need the less than or equal to, technically it is equal to when you're talking about an increasing or decreasing function, but they're not going to ding you a point if you just put less than. All right, for part C it says find the absolute minimum value of f on the closed interval -6 to 5. Now we want to be careful here because we're talking about an absolute minimum, not a relative minimum. If we want the relative minimum, then all we would be looking for is when f prime changes signs from negative to positive. So we would see that we have a relative minimum when x equals 2. But because we want an absolute minimum, we have to compare that relative minimum to any other possible relative minimums. So we're going to go through the same motions. We're going to find our critical points, and the way we find our critical points is we set the derivative equal to 0. So we'll say f prime of x equals 0. And then because we have the graph of f prime, we can see that f prime equals 0 at -2, at 2, and at 5. And so we'd say we could also say and 5. But our other critical points are our endpoints. So we can say our critical points are -6, -2, 2, and 5. And then the best way to go about this, instead of trying to explain why certain ones of these are not considered when we're doing our work, it's better to just evaluate all 4 of these and then look for the lowest value. So if I want to know f of -6, we already did that work in part A, part A, and so that answer is 3. F of -2 is actually given in our problem up here, so that's 7. F of 2, we're going to have to do some work here. It's going to be 7 plus the integral from -2 to 2 of f prime of x dx. That's just like what we did on part A. And so now we're looking for the integral from -2 to 2. And so we can see that that is just this semicircle. So it's going to be -1/2 pi times 2 squared. And then we can simplify that to be 7 minus 2 pi. And then f of 5, we already did that work in part A. We got 10 minus 2 pi. So the question is, what is the absolute minimum? So out of these 4 candidates, the lowest value, 10 minus 2 pi and 7 minus 2 pi, obviously 7 minus 2 pi is smaller. And then 3 and 7, 3 is smaller. So the question is 3 smaller than 7 minus 2 pi? And the answer is no, because 2 times pi, 2 times 3.14-ish is going to be 6 point something, so 7 minus 6 point something is going to be under 1. So our absolute minimum here is 7 minus 2 pi. As far as points go, you're going to get 1 point for considering all your critical points. So as long as you have all your critical points here, based on what you have here, you got that point. You're going to get 1 point for your answer with your justification. Now we don't have a lot of words here for justification, we just have a bunch of work. So evaluating all your critical points is considered your justification. So this part is worth 2 points. For part D, it says for each of these two things, f double prime of -5 and f double prime of 3, find the value or explain why it does not exist. So we are given f prime as a graph, and we are asking for the values of f double prime, which means we are looking for the derivative of this function at these points. So looking at -5, when x equals -5, right here, what is the derivative of this graph? What is the slope of this graph? And we can easily count. This is going to be down 2 over 4. So f double prime of -5 is going to be -1/2. So that one's pretty easy. It's just the slope of this function. Now f double prime of 3, well, if I look over here, f double prime of 3, I'm asking for what the derivative is of f prime. We can see that we can't take a derivative there because we have a corner. But notice it says find the value or explain why it does not exist. Explain why it does not exist. So we know that f double prime of 3 does not exist, but why? The reason is because if I try to take the second derivative from either side, they're not going to be the same value. So we can see that the derivative from the left-hand side, or left side, of 3, we can find the slope on the left-hand side. That's going to be 2. It's up 2 over 1. The derivative from the right side of 3, so that means the slope on this side of it, you can see that that slope is negative 1. Since the second derivative from the left is not the same as the second derivative from the right, we can say that the second derivative does not exist when x equals 3. And the reason we can say it does not exist is because there's a corner. So in terms of points, you're going to get 1 point for figuring out f double prime of negative 5. So this answer here. You're going to get 1 point for f double prime of 3 does not exist with your justification. So your justification should include the left-hand derivative, the right-hand derivative, and because they're not equal to each other, f prime has a corner, and therefore f double prime does not exist. So that is part D of this FRQ. So go ahead and grade yourself and get ready for the next problem. The next problem here is going to be 2016 number 3. This is a non-calculator problem. This is counting as a quiz, so you should be doing this on your own, setting a 12-minute timer, and then coming back and watching the next video to see how you did.